Hey gang, today we're going to be learning about scatter plots and lines of fit. You see up here in this box what you'll learn. You're going to learn to interpret scatter plots, identify correlations or relationships between data sets, and use lines of fit to model the data. So before we jump in, let's think about what a scatter plot is. A scatter plot is a graph that shows the relationship between two sets of data graphed as ordered pairs in a coordinate plane. So what that means is a scatter plot is a graph of a lot of dots like we see down here. Okay, see this graph of smoothies? We see calories, a relationship between calories and the amount of sugar in a smoothie. The points are often scattered around the graph, not necessarily in a clear pattern. Sometimes they are, sometimes they're not. So you have to determine what type of pattern the dots are showing. Oftentimes, our scatter plots will show trends in the data. A trend means either the data is going up or it's going down, okay, and it allows us to make a general prediction. So let's look at an example of a scatter plot and learn how do we interpret a scatter plot. So in this example, the scatter plot shows the amount of X, the x-axis is sugar in grams, and the y-axis shows the number of calories in 10 smoothies. Okay, so what we do is we can answer questions based on the data. So question A, how many calories are in a smoothie that contains 56 grams of sugar? So we look down here at our sugar, we find where 56 would be. 56 would be here between 54 and 58. So then we travel up our graph at 56 and we look there. How many calories would we have in 56 grams of sugar? Looks like it matches up with 270 calories. So that would be our answer right here, 270. Okay. How many grams of sugar in a smoothie that contains 320 calories? So now they're asking about the y-axis, 320 calories, and they want us to figure out the amount of grams of sugar. So we go up to 320, we go over to grams, and we go down here to from our dot. It looks like 70 grams of sugar. Okay, letter C. What tends to happen to the number of calories as the number of grams of sugar increases? So we look again at our grams of sugar. As our grams of sugar increase, goes up, what do we notice about the number of calories? If you look at these low sugar numbers down here, the calories are low. If we move up the sugar, we move up the calories. So what we would say to answer this question, what tends to happen to the number of calories as grams of sugar increases? The number of calories also increases. That brings us to correlation. Correlation is a relationship between the data sets. This looks similar to slope that we've seen before. The way the points are arranged on the scatter plot helps us decide what type of relationship or correlation the data might have. So here we see as the x-axis increases, as we move up the x-axis, the y-axis is also increasing, which causes our dots to go up in a positive correlation, a positive trend. Here we see as we move up the x-axis, what's happening to our dots? They're falling as we move up, which is a negative correlation. Okay, and then here we see just a random assortment of dots. Okay, this is a no correlation scatter plot. All right. So here we have some examples. How to identify correlations. We say, does the data show a positive, a negative, or no correlation? Remember, correlation means they have a relationship. So one thing affects the other. Okay, if we see a scatter plot, like we saw here, one thing doesn't affect the other. Okay, might be like Amount of pizza eaten on a rainy day. Does the rain matter to how much pizza we eat? No, it would not change. Okay? So here we look. Letter A, age and vehicles owned. So we look at the number of vehicles owned and the person's age over the years. Okay? So at age 20, there's not very many people owning cars. 25, between 20 and 25. Okay, we're at 4. 30, we've got 1 or 5. 35, we've got 2 or 6. 40, we have 2 or 5. Around 50, we have 4 or 7. 55, we have 3. There's all these spaces in between. So that would be a no correlation graph because there's no trend. As you get older, you own more cars, or as you get older, you own less cars. It's just kind of randomly scattered. That's a no correlation or no relationship trend. Let's look at letter B. Temperature and coat sales at a store. So we're going to take a look as the temperature goes up. Okay, as our temperature increases down here on the x-axis, you always start on the x. What happens to our coats sold per day? When it's 35 degrees, we sell around 60. When it's 70 degrees, we sell around 10 coats. And in between, it looks like as the temperature goes up, the coat sales go down. So in that case, we would say that is a negative correlation. As one goes up, one goes down. That's a negative correlation. Okay, positive, remember, is both are going up. Negative as one goes up, one goes down. And then no correlation is there's no relationship at all. Okay. Here we're looking at using lines of fit. I'm going to open my iPad real quick. Lines of fit to model data. When data show a positive or negative correlation, you can model the trend using a line of fit. Sorry about that. A line of fit is a line drawn Sorry for the interruption. Sherman came by to say hello to you guys. So here we're going to do lines of best fit. And we're going to make a scatter plot. So when data show a positive or negative correlation, you can model the trend using a line of fit. A line of fit is a line drawn on the scatter plot that is close to most of the data points. So in the blue box, the directions here tell us to make a scatter plot of this data in the example, decide whether the data can be modeled by a line, draw a line that appears to fit the data closely, okay, try to put it right in the middle, as many dots below it as above it, and then write an equation using 2 points on the line. The points do not have to represent actual data, but they must lie on the line of fit. Okay, so they don't have to be actual points out of this info, but they need to be on the line. So here's an example. The table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Okay. Interpret the slope and the y-intercept of the line of fit. So what we're doing, we're going to input weeks, and our output will be sales in millions of dollars. So I'm going to graph this. So we need to label our axes. Okay. So over here we have our y-axis, which is sales in millions. And down below we have our x-axis, which is weeks. Okay. I'm actually going to move this up a little bit so you can see a little better. Okay, let's start over here. So down here is our weeks. And up here, sales in millions. All right, so our weeks, our x-axis, just goes up by 1. So 1, 2, 3, 4, 5. Just going to do 5 million. So I got to make this 116. We can quite a bit. Okay. Over minus 17. We X the best form. Okay, that's it for scatter plots today. Thanks for watching. Let me know if you have questions.